Hey, welcome to this month's Power Hour. Today we're talking about gasoline direct injection. We got some tips on installing the injectors. It's a little more to it than what we've seen with traditional port style injectors. So I'm going to keep my hands relatively clean, free from cuts and nicks here. That's why I brought Corey in. He's typically behind the camera working the magic. He'll still be doing that, but he's going to jump in. We've put together a couple different videos. The interest of time, we did a little bit of pre-recording with some of this. Corey's going to walk us through that. And then he's going to also go through installing some seals here later in the presentation. So that being said, Corey, you can get back to the switchboard. I'm going to run back over to the computer and let's get started. Okay, so let's get the program started here. You can see I've got a lot of components laid out on the bench here. Some tools, we're going to show you how to do those today. The seal kit, we'll be installing that. And then, of course, want to highlight, we offer not just injectors, seals, we've got a complete program with the kits, the pumps, everything you need there. So let's get started with my presentation though. So GDI really is nothing new. It's been around, it's really gaining popularity. I'd say it's the predominant injection system that we're seeing in the shops here today. But in all reality, this has been around since the year 1925. Yes, 1925, 100 years ago was the first example of gasoline direct injection. Now it's gone through many different phases and significant changes since that time, but it was around 2007 that we started seeing it back in more popularity. GM introduced it with some of the lesser known models there, the Sky and the Solstice. I don't know if any of you have ever worked on those. You might find them in a museum here today. But GM reintroduced it in those model years. Then it quickly gained popularity with the Buick in the 3600 motor. Then Lexus and Infiniti jumped in with some of their high-end models as well. And from there, it really grew. By 2010, most manufacturers were using it as their predominant choice of fuel injection and continued to grow. But now here we are in 2025, and we're seeing a little bit of a slide back. And I'm going to address that here in some of the slides coming up. So direct injection is exactly as it says there. Instead of injecting the fuel into the intake manifold like we did with port style injection, Multec, all the different earlier versions, it's now going directly into the combustion chamber. And so there's a lot of changes there. Obviously, the pressures are going to be much different inside the chambers. So the fuel injection has to be a different pressure as well. So we're going to see significantly higher pressures. And we're going to, quite frankly, be testing these using the scan tool data pin and reading the pressure sensor on the rail versus hooking up our gauge. That being said, there's still a time and place for our fuel gauge. If we look at the schematic here, we can see that there's both a low pressure system and a high pressure side to this GDI system. It all starts at the tank. We've got the delivery side, and that's going to be what we call quote unquote low pressure. It's still going to be 40 to 60 PSI. Always look up service information to find the exact specification. That's going to supply the fuel to the GDI high pressure pump. That high pressure pump is going to be mounted on the engine, and it's going to be actuated by the camshaft. So again, all things new are kind of repeating history. Remember back in the days with carbureted vehicles, many of you may not, but it was actually actuated off the camshaft at one time. So we're back to cam-driven pumps here today. The high-pressure pump is going to be driven off the camshaft, and it's going to create the high pressure. Between 800 PSI all the way up to 2,800, getting close to 3,000 PSI on some applications. So again, we're probably not hooking our gauge to the high side. We're going to be using our scan tool to read the pressure there. So why? What is the benefits of GDI? Well, one of them here is increased volumetric efficiency. Why? Well, because it doesn't have to depend on that fuel mixture in the intake. And so now on the intake stroke here, we can see that the air is being drawn in, and then the injector is going to spray the fuel into that intake charge as the piston is moving down. Now, what this is going to do, first off, that is going to cool down the intake charge there. And that does a ton of different things here. By spraying this in, now if there's any hot rodders or maybe even some of the diesel guys that build performance pulling engines, they're used to water injection. And what that's doing is cooling down that charge, which in turn is increasing the density of it here. But by cooling that charge, it's going to have a reduction in NOx, which is significant here, but it's going to allow the air to move in more fully, and it's going to give a more dense charge here. So as we look at some scan data here, we're looking at a GM 3.6 liter engine here. We grabbed some scan data. We provided our own little math channel here. And so if you look at that third PID from the top, you can see volumetric efficiency. So where the cursor is, you can see that we're at 6,300 RPM, and our VE is at 93%. Now that's a really good volumetric efficiency number, but keep in mind this is at a port style, naturally aspirated engine. Let's fast forward to a newer one, couple years newer, different design here. We can look at our cursor. We're still at 6,300 RPM, and we've done the math here, and the volumetric efficiency is now at 105%. So significant improvement here in the way that the engine can flow air in and out of it, improving the efficiency, obviously the torque and horsepower rating of the engine. So simply by having the direct injection system, it allows for better breathing of the engine. So an additional benefit here is improved knock control. Not NOx, N-O-X, kind of talked about that already, but knock, like spark knock. And so with GDI, again, we've got fuel spraying into the intake charge, and it's going to cool that charge there. This is going to reduce the combustion temperature, which is going to reduce the likeliness of spark knock. That allows the design engineers to increase the spark advance and use a higher compression ratio here. So looking at some scan data again, here we can see an example of a GDI equipped vehicle using a Traverse again. As we're cruising down the road here, you can see the RPM. It's not really under acceleration. It's relatively steady. Yeah, the engine load varies a little bit depending on some increase in hills, etc. But look at the ignition timing. Second from the bottom, we can see we're over 50 degrees at steady cruise here. And so based on this design, engineers can do so much more things to the engine to increase the overall efficiency as well as to reduce emissions. But it's not perfect by any stretch of the imagination. There are definitely some faults with GDI systems. So as we look at the screen here, one of them is it's more costly to produce. So these GDI injectors are obviously a higher pressure. The rails are more expensive to produce. The injectors in turn have to be a different design, probably a little more precision put into these because of the demands and the pressures that they're under here. So it's more costly. Also, because the pressures are increased, they're noisier. Think about a diesel engine. Obviously significantly noisier, but GDI with this, when you're running over 2,000 PSI, that injector clicking on and off is very noisy. So any of you that have been under the hood of a vehicle in the last 10, 15 years, notice that there's significantly more foam in engine covers there to help the driver not notice all the clicking and clattering going on underneath the hood. That's done primarily to mask the sound of the GDI injection system here. Now, another detractor here, I guess for those of us who really enjoy tools and looking for excuses to buy more tools, well, here's your opportunity. We need a whole new set of tools to service the GDI systems. You're going to see those used here in some of these videos coming up. Additionally, a lot of these fuel lines are one-time use components. Now, we've addressed this in other previous presentations. If you're looking for more information on that, you can always go to our Standard Brand YouTube channel, look up some of our archived ones. We talk about this to great length. And a lot of these lines are going to be one-time use. So even if you have to remove the rail to do a timing job or an engine replacement or cylinder head job, you need to replace those one-time use lines there. Some other negative factors with the GDI system here: higher particulate matter emissions. I'll go into more detail on that here in just a second. And then obviously valve deposits. This is probably the one that's made the biggest headlines. We as technicians have seen this since the introduction of GDI, where we've got significant more valve or carbon deposits on the valves. Why is that? Well, on a port style engine, we've got the fuel being injected into the intake. It's mixing with the air, it's getting drawn past the valve, and it's going to clean. So that's where you've seen a lot of fuel manufacturers talk about their detergents. It actually cleans the carbon off of there. GDI, we don't have that opportunity. The fuel is injected after the valve. And so, yeah, it might touch that valve a little bit, but for the most part, it's going directly into the cylinder. And so it's not having the cleaning effect. But also due to some of the design characteristics, the PCV or the crankcase ventilation system on these engines are going to be much tighter and recirculate it through. So it's going to result in higher carbon deposits. That's a great service opportunity. And again, another great reason to keep up with that conversation with your customers about properly maintaining their vehicles, cleaning this before it turns into too big of a problem. But back to particulate matters, that's a serious issue with GDI engines. Now, different manufacturers have different solutions with that. One of them we've seen introduced in the last year with the Lincoln applications. They've included a new particulate filter, a gasoline particulate filter. We've been dealing with those on diesel trucks since the mid-2000s, but now we're seeing them included in gasoline applications. That's a result of GDI and the higher particulate matter that we're seeing in the exhaust side there. So that's one option there. But other manufacturers have combated it different ways here. One of them is by doing a hybrid injection system. So manufacturers such as Ford and Toyota have kind of gone back to a dual fuel system. And so here we see an example where it's using a port style injector. It's injecting into the intake manifold, as we've used for many years, combined with a GDI injector here. So here's a little cutaway. We were able to get from the auto show on a 2018 Ford 3.5 liter EcoBoost. And so you can see the port style injector located there, as well as the GDI injector. So again, for us as technicians, those of us in the parts business, great opportunity. We've got double the amount of injectors on this vehicle here. And Ford has a little bit of a unique injection strategy here. So as you look at the chart, you can see the low RPM range and lower load, it's going to run on port fuel injection. But then as RPMs and load increase, it's going to make the switch from port over to direct injection. So under heavier accelerations. Now, this is a little bit of a diagnostic challenge. I've run into this personally recently on a police cruiser where it had the dual system. And this thing would misfire at idle and low RPMs, but once you got into the higher RPM range, it cleaned up and ran differently. By observing fuel trims, it was very clear to see that it was a fueling issue at the lower RPM range. Long story short, this ended up having a faulty port style injector. So that's a new diagnostic scenario we're gonna have to keep in mind here as we've got these dual fuel systems. Which one is working, which one is not working, which one needs to be replaced, cleaned, etc. And so it gives a whole new set of service opportunities. Now, Toyota goes with a little bit of a different strategy here. And so they're going to kind of combine it here. So at the low RPM, low torque requirement here, they're going to use both of them. And so the GDI is always going to be firing, but they will bring in the port injection system for certain driving conditions. Under high load, they're going to remove the port, which seems a little counterintuitive, and rely solely on the direct injection system. But the direct injection or the GDI system on this Toyota is always going to be firing. So this is a challenge to technicians, and I'm going to remind you to always look up the operating characteristics for the particular vehicle you're working on to understand what that vehicle strategy is, because it's going to come into your diagnostic decision here. Now, before we get into the replacement tips here, just want to kind of wrap up here with a little bit of talk about strategy. There's different fueling modes here. First one is homogenous, then stratified charge, and then catalyst warm-up. So there's different fueling strategies that are allowed to be used here by GDI. So in the homogeneous mode here, this is going to be an even equal spread of the air-fuel mixture under all operating conditions. So at this point here, the piston is coming down. You can see in the illustration on the intake stroke. So the combustion charge or the combustion chamber is not under pressure. It'll be under a negative pressure, right? We're drawing air in as the piston's coming down. And so by injecting fuel at this point, it's going to mix with the air coming in, and it's going to have time to swirl. It's going to come back up on the compression stroke. And so it's going to have time to mix there. And so not a lot of work is required by the injector here because it's injecting into really atmospheric pressure at this point. And so we can see here by looking at injector pulse width. Remember in port style injected vehicles, in order to get more fuel in, the pulse width was increased. But as we look here, we can see under hard acceleration with this traverse with a 3.6 liter, look at the injector duty cycle from bank 1, bank 2, 3 milliseconds under hard acceleration. Not a lot of pulse width there. Well, how are they doing this? It's being done with increasing the pressure. So in order to get more fuel volume in, the pressure is going to be increased there. So if we look at that bottom data PID there, we can see it's at 1943 PSI. So rather than increasing the pulse width significantly, now the pressure is going to be increased significantly to get more volume of fuel in there. Another fueling mode here is referred to as stratified charge. Now, not a lot of manufacturers in the U.S. use this. We see it more in the European manufacturers here. But as the piston is coming up on the compression stroke, ready to light off the flame, it's going to, at the last minute, send an injection charge here. So this has to overcome a significant amount of pressure in the combustion chamber there. But this just-in-time delivery allows for a much leaner mixture here. And so that's going to improve fuel economy, and it's going to achieve the desired results here as far as engine performance, but it's going to have an offsetting result in tailpipe emissions. And so it's used in limited amounts here. And so, again, some of the reasons why they might not do this, the lean mixture requires an NOx trap, and so different manufacturers have to put more emissions devices in the exhaust side here. And then as a result, they have to do more work to reduce the exhaust gas temperature there. And then we see what's referred to as catalyst sulfur deactivation. By using this significantly leaner mode here, it's going to change the chemical reactions happening inside the catalyst there. And so that is something that manufacturers have to keep in mind there. The final mode here is referred to as catalyst warming injection. Now we see this a lot of manufacturers significantly changing the injection timing or using multiple injection pulses here in order to wake up the catalytic converter, warm it up. So it's basically overfueling. If you go back to the diesel world, which is one of the more original direct injections, for emissions also, they've got that additional pulse. And so they're adding more fuel to help fire up the emission system. Same thing's happening with these vehicles. So if we look at the red line here, we can see this is our cylinder pressure. The blue line, the dotted one there, is our valve lift. And so the yellow stripes are where fuel is going to be injected into the cylinder. So on the intake path here, low pressure, the main injection is going to occur. But then as the piston is ready to start coming up on the compression stroke, now we're in a stratified injection there. That additional fuel is going to help additional heat get into the catalyst there. And so this is going to wake up the catalytic converter and start cleaning up that tailpipe emissions much further in the drive cycle. So we can see these different modes here being used differently, helps engineers achieve a much different goal. And so by using these higher pressures, much more specific injection, just a lot more flexibility to tighten up performance as well as emissions. All right, well, you made it through the theory and operation portion. Now let's talk about some tips, what it takes to actually replace these things. You've done the diagnostics, you understand that there's been a problem here, and so now let's dig into what it takes to replace one of these things. So first thing I'm going to say, use caution when removing the rail. We always need to use the right tools. Now we'll talk about some of these tools here. Replace the seals anytime the injector is removed. So let's say we're pulling a fuel rail because we've got one faulty injector. I'm going to definitely recommend that you replace all of the injectors on that rail. They've all probably got the same amount of wear and runtime on them. So we can definitely make a case for replacing all of them. But I also understand in the real world, quite often that customer wants to replace just one injector. So if we're pulling that rail, we need to replace the seals on the other injectors here. Whenever you've removed one of these lines and you've loosened any of those, you need to discard them, especially if they got the yellow tag on them, and then replace them the next time you do them. So that being said, let's jump to our first video. As I mentioned, Corey went ahead and did a little bit of pre-work for this. And so this first one here, we've got a video with a friend of ours who works at a dealership. Now I'm going to step over to the other side here and look at kind of the resulting fuel rails here. You can see we've got one that's relatively straight. One of them has got some significant curvature to it here. And this came from our friend at the dealership. He does these things all the time. So let's take a look at his procedure here and how he uses extreme caution. But sometimes we're still left with not the desirable outcome we're looking for.
Removing the fuel rails and the fuel injectors on these engines can be pretty difficult, even when using the OE service tools. So in this video, we're going to show you a few tricks on how to hopefully more easily remove these components without damaging them. And we'll start by identifying the parts we're going to be working on. So on the top, we have the right fuel rail, or the passenger side fuel rail. And then on the bottom, of course, we have the left, or the driver's side fuel rail. We also have these two fuel lines that we're going to need to remove in order to pull the rails out. So we'll begin there. And the technician is now going to remove those two fuel lines. But before he started doing this, just keep in mind, he did bleed the high pressure out of the fuel rails themselves. And so now he's going to remove the bolts that hold the lines in place and then remove them from the engine. This is a very important note here. We need to dispose of these two parts. These two lines are one-time use components. Once you take those loose, you just need to throw those away and replace them when putting everything back together. All right, so with that done, the technician took a few moments and disconnected all the wiring that connected to the injectors and the fuel rail sensor. And now he's going to go ahead and loosen up the bolts that hold the fuel rails to the cylinder head to go ahead and prepare the rails for removal. Now, before we remove the fuel rails, let's discuss these two tools. Now, they're both necessary for the operation, and the long tool with the hook on the end is going to be used to exert an upwards force on the fuel rail up and away from the engine. And then the small tool here is going to be used to redirect that force at an angle away from the cylinder head. So these two tools are actually working together to try to put not only the appropriate force, but the appropriate direction on the fuel rails and the injectors. So let's take a look at how this works. So he begins with the long tool, and this is going to be used to apply an upwards force. But the rails and the injectors are connected into the cylinder head at an angle. He really doesn't have much of a choice but to lift straight up with that tool. That's really the only option. And so he's going to use the small tool to redirect the force off to an angle. So while he's lifting up, he's also going to be pushing in with the smaller tool, and the idea is to cause the rail to exit the cylinder head at the right angle. Now he's in the rear of this. He hasn't been prying on the center of the rail, mostly because the center of the rail underneath has all the wiring to the injectors, and he's afraid of damaging that wiring. That's the last thing we want to do. Now, this specific rail here gave him a lot of trouble. And keep in mind, he's done this many times, but still having a lot of problems getting this rail loose. And so you can see, even with it almost out, it's still a little difficult, but it's finally broken loose. And now we can go over to the other side and do the same procedure. And so now we can go to the other side and do the same thing, keeping in mind that we don't want to go straight up because it will twist the tips of the injectors and sometimes bend the fuel rail as well. So we need to use both tools. But again here, this one's being just as stubborn, actually a little bit more stubborn. But there he is, he's got it, and it's loose now. And he's going to lift that right out of its position. And what we're going to do is we're going to take both rails over to the bench and just take a look at them. And of course, despite his best efforts and lots of experience pulling these rails, we can see here that the right fuel rail is still bent. This thing was really stuck in there. They were both pretty well stuck, but that right side gave a lot more trouble. It was a tough battle, and even though he used the right tools, and even though he used a method that has worked for him much better than even the OE service tools and procedures, it's still bent. So let's take a look at the left fuel rail. Now, the left fuel rail was tight, but nowhere near the same way as the right side, and he was able to get that one out without bending either the fuel rail or the injectors. So the point here is, even with the right tools, the right know-how, you can still bend these, and really it's just a byproduct of how long they are and how tight they get stuck in the cylinder head. But if you use the right technique and the right tools, you can usually minimize the damage to the fuel rail. Now, many technicians have decided that, the best course of action on these is if you have to pull the fuel rail to get to the injectors for any reason, they usually just go ahead and replace the fuel rail with those new injectors that they're pulling out. Or if you're just pulling it out for service to the cylinder head, again, a lot of technicians are now just replacing the fuel rail. That way we don't have to worry about these bends, and we know that we're going to get a good solid system put back in place, especially if we can go ahead and put new injectors in or reseal the old injectors.
Okay, so again, hopefully you have a new appreciation for what it takes to do these, even though you use that caution. I've been through this procedure myself. I've done a couple of the VLOM plates, variable lift oil manifolds on GM V8 applications, and I followed his procedure. I've been very fortunate to have good results, but understanding depending on the conditions and where the vehicle is located, this type of stuff happens. So beware, use caution. No, we cannot put this in the vise and straighten it back out again. This is time to replace the rail. So now you see how it can go bad. Now I'm going to tee it up and ask Corey to walk us through doing it on a GM 3.6 liter engine and kind of walk through the procedure there. We've got some additional tools here. So you can see this little J-hook tool here. You're going to notice how he's going to install it on the vehicle, and then he will use this to pull it out. Now those V6 applications, you got to keep in mind that those rails are really tight, close to each other. But let's look at a successful replacement here with this particular tool.
Now, to begin with, there's a few steps we have to take to make sure that, one, we're safe, and two, we have everything ready for the removal of the injectors. And that's going to include removing the battery or disconnecting the battery. And then we need to also depressurize the fuel system on this vehicle. Now, in our case, we're using a snap-on tool, and there's actually a specific function within the tool that allows us to depressurize the fuel system before we go and remove any connections to the fuel causing any pressure issues. So we'll do that. We'll get the depressurization done. We'll get the battery disconnected, and then we'll go from there. So now with our system depressurized, we've gone ahead and taken the top cover off. We got our oil filler cap off, and then we've also removed our hosing assembly and baffle that sits on top of our intake manifold. And now we can start working towards getting the manifold off and working our way to the injectors themselves. Now that we have our intake manifold and our throttle body removed, we can now remove the gasket and the insulator that are sitting on top of the fuel rails themselves. And as you can see, we now have access to our rails. One rail on the back side, one rail facing us on the front side. We're now going to start working to get those rails and those injectors out. But first we have to come over to our inlet and outlet on our fuel lines that are going to be coming from and to the pump, sending that fuel to the rails to supply the injectors. And since we have access now to the fuel rails and the fuel lines, you can see we've easily pulled this fuel line off, and it's all one piece. It's going to be a 17 millimeter nut that's going to hold these on. They're really not on there that tight, so you can just use a wrench. But a big note to make here is this is not a reusable line. Once you remove this line, you will want to throw this away and have a new line to replace it with when you put everything back together. It's very important that you do replace this line. With all of our mounting bolts removed from the fuel rails themselves, we can now use our specialty tool on both sides in the middle to remove the rail itself. Now it's important to use these specialty tools because it has a J hook that goes on one side that mounts to this arm, and then the other side of the tool is going to go into the original mounting bolt. And what that's going to do is going to apply pressure both to the block and the rail, pulling it up at an even pace without bending the rail or the injector tips as you're bringing those out. So what we'll do is we'll turn these at the same time, and that's going to break free the injector rail. And now that we have the rail broken free, we used our specialty tool to break the injectors free from their ports. We can now pull the fuel rail out, but I will tell you, it's a lot harder than it's going to look when you first go to pull it out. There are a lot of things that you're going to have to kind of wiggle and shift out of the way to get the fuel rail to come all the way up. And then if we spin the rail over, you'll see there are two tabs here and here that just have a grommet attached to them, and you're going to want to remove those grommets in order to get the rail all the way out. But essentially, once you have those removed and you get the wiggling done, the rail will pull straight up. Now, one thing I do want to mention, if we spin this all the way over with the injectors facing at the top, if you were just going to replace the seals on this injector, you will still need a specialty tool to put the new seals on and get them mated to the grooves that they go in. We talked about throwing the old line away. Here's that new line, and we are going to replace that new. Again, another important note, make sure you leave these rubber tips on these lines until the exact moment that you're going to put these lines in place. It's just a simple way to keep debris and other things from getting inside the line and causing any type of trash or contaminants getting into the new injectors. So earlier in the video, when we were removing the injectors, we talked about using a specialty tool as well as a flathead screwdriver to remove these clips that hold the injector onto the rail itself. Now we have these reinstalled, these new injectors. However, we do want to show you what you're going to be running into with this. So on the injector itself, when it goes into the housing, it's going to have this retaining clip that pops on and locks the injector into the rail. You basically have a tab on either side as well as one in the middle. And that tab is going to lock into place on this clip instead of keep the injector from moving around. Now, to get that on there, we'll go back to the specialty tool. And what's great about this tool is, you have a lot going on trying to get this injector in, lined up in the right spot. So holding and maintaining the position of that clip is difficult enough as it is. With this tool, there's actually a magnet inside of the clip side. So you'll take the clip, you'll put it in backwards to where it holds on to the magnet, and then when it comes time to lock it into the injector, you'll have this clip already into the tool. You'll place it onto the rail here, and then the back side is going to apply pressure to the rail itself right here. And once you have it lined up correctly, you'll be able to squeeze the tool and pop that clip back on, retaining the injector into the rail. That way we have a proper seal and it'll have proper function when the vehicle gets ready to run again. And now with our injector rail replaced with 3 new injectors, prior to installing that rail, we're going to clean the injector ports. That's a specialty tool that comes with 2 different components. We're going to have a brass, somewhat pipe cleaner looking tool that's going to shine up the port where the injector is going to go in. And once we have that done on all 3, we're going to remove the pipe cleaner style brass tool, and we're going to add the other tool that comes with it, which is going to be a brush to make sure that we don't have any debris or anything else within that port. Just cleaning those ports up very nice so that we get a perfect, accurate seal with those new injectors once that rail goes in. Now that we have the new injectors reinstalled onto the rail, we can now guide the rail back into place. And again, we've already cleaned those ports out, so we know we're safe there. We don't have any debris in the system. We get that rail back in place, we'll get it locked back down, and then we'll do the exact opposite. We'll go backwards and go to the other side of the engine and pull the other rail and replace those 3 injectors. That way we have a completely new fuel injection system on this vehicle. Now again, once we have both completed, we're going to replace that fuel supply line from the pump to the rails. Since that was a throwaway piece and we got to put a new one on each time, we'll replace that. We'll get the pump replaced. And then it's just a simple process of getting the rest of the components back in place, such as our intake manifold, our throttle body, all those components we removed to gain access to the rails themselves. We'll put those back on. We'll get our battery re-energized. And then all we need to do at that point is put the key in the ignition, let it sit in the AC position for just a second so we can get some fuel running up to the pump, and then we'll start cranking. Now, it will take a few seconds to get the car to turn over because you do have to build some high-pressure fuel in that high-pressure fuel pump. So let it crank, and if it keeps going for 10 to 15, 20 seconds, back off and try it again, and you will quickly get that pressure built up to the high-pressure fuel pump, and that'll feed that fuel to the rails, and we'll get these injectors running like brand new.
All right, so hopefully you have a better understanding of a successful way of doing it on the V6 applications there and using some of these tools here. Now for kind of a final demonstration, I'm going to turn over to Corey here in the studio. And so we've got one of these 6.2 liter injectors, one of the ones that we saw on that rail there. And so in the scenario that we have to reuse one of these injectors, or let's say we did a cylinder head job, or in that case I talked about where I'm pulling the rail to do the VLOM manifold, I'm not going to replace the injectors, but we do need to replace the seals. These are one-time use here. And so I'm going to turn this over to Corey. He's going to install some new seals on this particular injector.
Okay, so when we're talking about resealing a GDI injector, one thing to keep in mind is it's going to be a little different on every application. This is, for example, a 6.2 liter GM. So we're going to have an upper sealing system, a lower sealing system, a new clamp for the rail when we put it back on. And also, these may not have come with a dust shield that slides down to the base of the injector. If yours comes with one in the kit, go ahead and use it. And if yours did have one, replace that as well. This is just an added benefit, and in most cases, they didn't have them originally. But the point I'm making here is make sure you use the full kit. Now, we're also going to need a few tools to get this done properly. Now, there's differences of opinion on how to get these seals off. There are some folks that have a specific pick that they like to use or a specific pocket knife. In my example here, I'm going to use just a new box cutter blade, but I'm going to show you I'm going to be very easy getting that off. Definitely don't want to be too aggressive and end up marring the finish or damaging the injector. We're also going to need a small pick, and that's just going to help us get this seal off, but I'll show you a little trick we can use with that to help you out whenever you get this first seal on. Now, to get the lower seals, the inboard and outboard seals on, we're going to need a few tools for that as well. So we have a cone for the inboard seal. We have a cone for the outboard seal. We also have a tool that helps us get those new seals down those cones, because this is actually going to resize this and make it bigger as it goes down, and then we'll resize it onto the injector with the actual forming tool. So these are going to help get the new seals on, and then we're going to make sure that it's formed to that groove with this tool when we get them in their locations. So we'll get these out of the way, and we'll start by removing the old seals. So again, I'm just going to use a little pick here, get up underneath that O-ring, and just slide that off. And so our old O-ring is out of the way. And now underneath that, you'll notice there's actually a split on this spacer. Just slide in there, pull it out, and you're good to go. Now we need to get to the inboard and outboard seals. This is where we need to be a little extra careful. And what I'm going to do is I'm going to take this blade and I'm going to try to get right up underneath that seal. And then I'm actually not going to spin the blade or anything. I'm just going to rotate my hand, and I can watch that line cut. And there we go. No mar to the finish, no damage to the injector, and the first seal is out. And I'm just going to repeat that with the lower seal. And there we have it. So both seals are off now. and we're ready to reseal this injector. And so again, we're going to start up here at the top. We have our new spacer. Remember, this does have a split, so we'll be able to just slide that on with the split, get it into position, take our new O-ring, slide that on, and now our upper sealing system is taken care of, and we can get to the lower inboard and outboard seals. Now to start this, I'm actually going to take the first cone. This is the longer of the two, and that's going to go over not only the end of the injector, but that first groove, that outboard seal. And we're going to take one of the newer seals. We're going to slide it on just a little bit until we start feeling resistance. And then we're going to get our little helper tool here. What I will say, just a quick tip, put your thumb right before the recess. And I say that because once you get to about this point of the cone, this will just slide it right on, and it may pass that. It's okay if it does, just pull it back down, but if you want to save yourself the hassle, just put your thumb here, give a little squeeze on this, and just slide until it pops into the groove. And as you see, it's there. Now what we're going to do is just by hand, and these are kind of malleable at this point, is form these into the groove just a little bit before we use the forming tool itself. And at that point, we'll take our forming tool. We're going to slide that on all the way. And then as we slowly back it off, we're going to spin. And there we have it. Our inboard seal is on, it's in place, and we know it's in the right spot. Now here's where that pick's going to come in handy. That first tool that we used is going to get caught in there. No worries. We'll push it out, get it out of the way. Now we're done with our pick. And now we can take our outboard cone. We can put that on the injector. New seal. We'll get it up there just a little bit. And I'm going to do the same thing here. I'm going to put my thumb on that inboard seal so that I don't go across it or damage it with this tool in the process. So I'll do the same thing here. We'll slide that down into place. And there we go. And now again, I can just somewhat form that prior to using the forming tool. Get it right where it needs to be. Take our forming tool, slide it down, and then I'm going to slowly back out. And there we have it. Both our inboard and outboard seals are now new and replaced. Our upper sealing mechanism is new and replaced. And now we can take that new dust shield, slide it down, and this injector is ready to be put back on the rail, new clip installed, and back into the vehicle. Now hopefully this will give you a little bit better understanding of how to do this. And again, this is on a 6.2 liter, so you would have a bank of 4. So the kit would come with 4 of the necessary components for that bank. So generally speaking, if you're going to pull one, you can do 4 at the same time. If you just want to do a reseal and you know that the injectors are good and still working. And with that, Ryan, I'll give it back to you.
Cool. Thanks, Corey. Appreciate that. Looked like there's no blood involved on this particular instance, so good job on that. Thanks for that. And hopefully everybody understands now what it takes to resize these things. Now we got to keep in mind, as you've seen in some of our videos, we need to make sure that the ports are very clean when we're putting them back into the intake there. And so I kind of want to go back and share one of the horror stories I ran across here recently. Shop called me in just for some advice. They ran into one of these Ford Transit vans. Now this was owned by a car wash chemical company, and their cleaning crew every Saturday would wash their own vehicles, and this included power washing underneath the hood. And so if you're familiar with these intake designs, you can see the intake on the right hand side of the image here. You can see that there's the pockets where the bolts go down. Now those are pockets. And so if somebody's power washing the engine, they don't dry it off, it's going to sit with the water on there. Now over time, that water might evaporate, boil, etc. But what happened here, it got so corroded. And so the shop had to use a Dremel tool And he eventually said, forget it, we're just using a torch. And they had to destroy the upper plenum here in order to get the bolts out of that. But it didn't stop there. These injectors were so seized into the cylinder head at this point. This one ultimately ended up with a complete engine replacement. The vehicle had a ton of miles on it. It already needed a couple injectors. These things were so seized into the cylinder head. By the time we actually got them out, you can see different methods here of, breaking the top off, threading bolts in, using slide hammers, all kinds of stuff to get this apart. The cylinder heads were so corroded. The aluminum was so corroded on this thing that it was deemed it's more effective to just go ahead and replace the engine at this point. Think of the timing components, all the other stuff that had additional wear, and so it was less expensive to replace the engine. I've since heard horror stories, same thing on the Ram ProMaster vans, where the cowl, the windshield wiper cowl is there, and if the drain isn't working properly or that cowl's not seated properly, it does the same thing. It leaks water onto the intake manifold. It sits there, it causes corrosion, and so these shops are having nightmares trying to get the intake off or even to pull the injectors out when they get them out. By the time you're going to clean it with this little copper brush here, it's not doing anything. You almost have to use a reamer to clean it out. Now it's too loose, so by the time you put the injector in, it's not able to seal there anymore. So be aware of that. Inspect some of your customers' vehicles as they're bringing into you for fuel injection problems, or if you make the determination that, yes, we have a faulty injector, look at what it's going to take to get that injector out. Is it serviceable? Is there additional damage? Do we need to stop and have an additional conversation with the customer? So a couple of key takeaways. Hopefully you've learned a lot here. You've seen some of our demos here. A couple of key takeaways: always use caution. As Corey mentioned in his video, it's always best practice to disconnect the battery. We're going to need to replace or depressurize the fuel system before disconnecting the battery. You can do it with a scan tool, as shown there. Sometimes if you let it sit for 10-15 minutes or just verify with a scan tool, the pressure will bleed off relatively quickly on these high pressure systems, but always be careful with this. Make sure you've got the right tools. As you see here today, we've got a tool kit with a little slide hammer that slides over the injector and helps get it out. We've got the hook tool here where you're going to thread this on and remove the rail. Must have is the injector seal replacement kit along with the brush there. Make sure you're using the right procedure. You can see, even though our friend at the dealership had a lot of experience here, is well versed in the procedure, mistakes still happen. Or not mistakes, but errors. And so do what you can to prevent that as well. And my final recommendation is obviously going to be to replace these in sets. If you get a high mileage vehicle, it's got a lot of wear and tear on the one injector. Who's to say that the other ones on at least that same bank don't have the same amount? You're already in there doing the labor. Let's go ahead and keep our customer, keep them out of the shop for a while and replace the entire set. Well, that's it for today. Couple of takeaways here. If you're looking for more information on this, go to our Standard Brand YouTube channel and just type in GDI. We've got a ton of informational videos, not only about the product, but about the procedures. The videos that we've shown here today are going to be uploaded on there. Ton of additional tips, diagnostics, etc. Go to our YouTube channel, find out more. Or if you're looking for more information there, go to standardbrand.com. You can find out more about the program. But also, if you click on the training tab there, you can find out additional resources and piece of information. So before we completely wrap it up here, I've been seeing a couple comments come in. Corey's been answering them. Not only is he our hand model, he's answering behind the screen here today. So what questions do we want to bring forth to the audience?
Well, you know what, Ryan? There's one that I probably could have addressed when I showed how to do that seal, but it's a great question. I was going to answer it behind the scenes, but I want to make sure everybody hears this. Question came through: what about lubricating those seals? You showed how to put them on, but why didn't you lubricate it?
Yep, definitely. Yeah, it's always a good opportunity. We don't want to cut these, especially we still have an O-ring here at the top of the injector that's going to go into the rail. And so, and you'll be using that clip, it's very important to put the clips back onto these things. I've seen a lot of technicians not use the clips. Well, that doesn't always end real well. And so it's a good idea to use a small amount of, I still prefer like just clean motor oil. Just get a little bit of lubrication on these things. I still in my toolbox have trans gel. It's an assembly lube. Just put a little bit on here. We don't want to risk rolling this or damaging it there. Same thing with these. We don't want to put a whole lot on, but just a little bit of lubrication is going to help with the insertion there. And yeah, so one other question came in, talked about, mentioned replacing them in sets. What's the best practice? Again, I understand customers vote with their wallets quite often and make economic decisions based on that. But best case scenario is to install a complete set. Yes, ours are all new, so they're going to be matched upon assembly. So you're not worried about this one's flowing more than the other one. As with all of our S&P injectors, they're all built and calibrated upon assembly. And so you can verify that they're going to be delivering the correct amount of fuel there. As I mentioned here, we've got Stratified, we've got these different charges happening here. Why take a risk with an injector that may or may not be delivering the right amount of fuel, and it's going to have significant impacts on the vehicle there itself. So thanks everybody for tuning in, and we look forward to seeing you next month.